Today, we're diving into something that seems simple, but it's really not. It's a game with a spinner, and on the surface, it looks totally straightforward. But trust me, it hides this incredible illusion about how probability really works. So let me ask you something that's going to sound a little weird. What if a 50% chance wasn't actually a 50% chance? I know, it sounds impossible, right? But what if having a 50-50 shot at each try doesn't mean you have a 50-50 shot at winning the whole thing? To get our heads around this, we're going to look at a super simple game, one played in a classroom. But don't let its simplicity fool you. This little game unlocks a pretty powerful and honestly counterintuitive secret about probability. Okay, so here it is. It's called the track meet game. And yeah, it was used with a bunch of fourth graders. But the crazy part, the results didn't just surprise the kids, they totally baffled the teachers. All right, the rules are about as easy as it gets. You've got 3 runners. Rule 1, you spin the spinner. Rule 2, whatever color it lands on, that runner moves up 1 space. And Rule 3, first one to make it 6 steps to the finish line wins. That's it. Super simple, right? Now, here's the key piece of the puzzle, the spinner itself. As you can see, it's not split evenly. Blue gets a massive half of the board, so that's a 50% chance on any given spin. Then you've got red and yellow, and they each have a quarter, so a 25% chance. Okay, so this is the big question, the one we're here to answer. With blue having that big 50% chunk of the spinner, what do you think the probability is that blue wins the entire race? Now, I'm guessing your gut, just like mine, is screaming 50%, right? I mean, if blue has a 50% chance on every single spin, it feels obvious that it should win about half the races. It just makes perfect logical sense. And that right there is the illusion. Because what actually happened in that classroom, it wasn't just a little bit off. It wasn't even close. Okay, so let's look at the proof. I mean, these are the actual charts the students drew up themselves. You don't even need to read the numbers. Just look at how long that blue bar is compared to the others. You can immediately tell something funky is going on. Let's put some numbers to it. So in one class, they played 45 races. Now, if it was a 50% win rate, blue should have won, 22, maybe 23 times? But nope. Blue won 32 times. That's a 71% win rate. Just way, way higher than you'd ever guess. And this is where the researchers got really interested. They had to ask, okay, was this just a fluke? Did this one class just get weird, lucky results? Or was there something baked into the rules of the game itself that was causing this? So to really find out, they needed more data, a lot more. They fired up the computers and ran simulations of the exact same game, not just 45 times, but tens of thousands of times, to see what the true odds were. And, wow, the results were fascinating. It turns out the secret sauce is the length of the race. Look at this. For a tiny one-step race, blue wins 60% of the time. Okay, that's higher than 50, but it's not insane. But look what happens when we go to a 6-step race, just like in the classroom. Blue's win rate skyrockets to 82%. And from there, the longer the track, the more ridiculous Blue's advantage gets. I mean, look at this. Once you get to a 50-step race, it's basically game over before it even starts. Blue's victory becomes a near certainty. It's going to win pretty much 100% of the time. That initial 50% chance per spin just snowballs into total, complete dominance. So this gets us back to the big why. How does a 50% chance on each spin turn into an 82% chance to win the whole race? Where does that extra advantage come from? Okay, here's the trick. Our brains are accidentally mixing up 2 totally different things. The chance of a single spin is one thing. That's a simple one-off event. But the chance of winning the race, that's a whole different beast. That's about the outcome of a long sequence of spins. It's not just about getting more turns. It's about getting to the finish line first. Think about it like this. It's all about the power of getting a lead. Because blue has more chances, it's just naturally going to pull ahead more often. And once it's in the lead, it still has that 50% chance on every single spin to pull even further ahead. Meanwhile, red and yellow have to get lucky just to catch up. It's about building a lead that becomes so big it's almost impossible for the others to overcome. Let's put it really simply. To win that 6-step race, blue just has to land on its color 6 times before red or yellow do. And of course, that very last spin, the winning spin, has to be blue. When you think about all the possible ways the game can play out,
The scenarios where blue wins are just, well, they're way more common. Okay, don't let this formula scare you. You really don't have to get it. But what this thing does is pretty cool. It's basically the way mathematicians can add up every single possible combination of spins where blue ends up winning. And when you run all those numbers, yep, you land right at 82%.
All right, so let's wrap this up. What's the big lesson here from this little classroom game? It's simple. A small advantage, if it's consistent, can turn into a huge, huge win. So really, this whole thing teaches us a few really powerful ideas. One, a small, steady edge can snowball into an unstoppable force. Two, the odds of a whole series of things happening is not the same as the odds of just one thing happening. And maybe most importantly, three, when it comes to probability, you can't always trust your gut. And that leaves us with one final thought to chew on. Because, let's be honest, this was never really just about a spinner game, was it? So where else do you see this principle at play? In investing, in sports, maybe even in your career. Where do those small, consistent advantages, day after day, add up to a near certain victory? Once you start looking for it, you'll realize the answer is pretty much everywhere.